Funding for this program was provided by the Annenberg CPB project. Additional funding provided by the people of Dow, the company that lets you do great things. The 8,000 scientists of the Eastman Kodak Company. The Exxon Education Foundation on behalf of Exxon scientists. And
our world is surrounded by calculus. From computers to economics to science to engineering to business and even medicine. Calculus is all around us.
I once drove with my family to the Sequoia Redwoods, and I found myself standing in awe of their magnificent wonder. To get there, we drove on the expansive interstate highway that connects this great country. Little did my family know that during this trip we experienced calculus. Our car both accelerated and slowed on our trip to the glorious and magnificent woods of the Redwoods.
Don't believe it? Well, let's try it out. For this problem, we'll use the definite integral and the fundamental theorem of calculus to solve it. Say this hot sports car is traveling down the freeway exit ramp and is reducing its velocity. We'll say its velocity is given by the equation v of t equals 100 minus 20 times the quantity t plus 1 to the 1/2, where v of t is in feet per second, and t is the number of seconds since it started slowing down. And we want to find how far the car traveled while it was braking. So, to solve this problem, we'll need some help of the definite integral. Let's say this hot sports car brakes for a period of 8 seconds. Then our limits of integration will be from 0 to 8. Now comes the fun part. We integrate! According to the fundamental theorem of calculus, we take the integral of the velocity and end up with this next equation. X of t equals 100x minus the quantity 40 divided by 3 times the quantity t plus 1 to the 3/2 integrated from 0 to 8. Now all we have to do is plug and chug. So, this hot sports car travels 453 1/3 feet in 8 seconds. Jeepers, that's a long way. So, remember, when you come to another definite integral problem, follow these important steps. Define it, understand it, do it, and apply it. Remember, math is especially fun when definite integrals are around. Hey, it looks like we have time for one more definite integral problem. What's the definite integral of 1 over cabin? Natural log cabin! Ha 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 ha!
Ah, yes, the automobile. Such a wondrous invention by Mr. Ford. It has served as transportation for many years and will probably serve for transportation for many more. And of course, as always, we can find its acceleration and velocity using calculus. And of course, the fundamental theorem of calculus. The fundamental theorem provides a way for finding definite integrals without using limit processes by using many different formulas to find antiderivatives. This realization made by both Newton and Leibniz was key to the massive proliferation of analytic results after their work became known. Differential equations relate an unknown function to its derivatives and are ubiquitous in the sciences, just as calculus is ubiquitous to everything. It can be related between one thing and another thing, to this and to that, and that is what makes it very majestical, just like those great redwood trees.
Funding for this program was provided by the Annenberg CPB Project.